Right, I'd like to thank first of all the Council for giving me this prestigious award. I'd like to thank all my colleagues and collaborators over the many years who've put together ideas and come up with a lot of the information that I'm going to be talking about. I'd like to thank my family for supporting me and letting me go off to EAP every year. And I'd particularly like to dedicate my talk to my two young granddaughters who were born in the past 13 months. And hopefully they will have a future that has lower emissions from livestock, but they will still have the ability to eat meat and milk if they want to. Okay, so sustainable intensification of animal production, what does it mean? Now, why did I choose that topic? Well, in 2011, the Foresight report was published on the future of food and farming. And the Foresight Committee was set up under Sir John Beddington to look at the problems facing the world and how we could address that and supply food for people in the future. So you've all seen this graph of population growth. So I was born sometime in the last century when there was 2.8 billion people on the planet. Today there's about 7.7, and in 2050 it's predicted that the world population will exceed 9 billion. So we could say, how can we feed these people? But I don't think there's much trouble in being able to feed them. It's how should we feed these people? And what the Foresight Committee came up with was a series of challenges. So there's the challenge of balancing future demand and supply sustainably, addressing the threat of future volatility in the food system, ending hunger, meeting the challenges of a low-emissions world, maintaining biodiversity and ecosystem services while feeding the world. And the final conclusion was that global food supply will need to increase without use of substantially more land and with diminishing impact on the environment. And this means that sustainable intensification is a necessity. So that's where the title of my talk came from. So what does it mean for animals? If we look at sustainability, then most people think sustainability is all about the environment, and that has assumed huge significance recently. But there's actually three pillars of sustainability. There's also the social pillar of sustainability, and this morning we've heard about ethics and morals. There's also, as well as the ethical duty to animals, the ethical duty to societies. We don't want big corporations exploiting poor African countries and things like that. So there's all sorts of social dimensions to producing food. And then there's economic. Now, economics is a bad word in terms of the environment and social aspects, but if something's not economically sustainable, then it won't be sustainable at all. We heard this morning a large proportion of Belgian farmers went out of business. We've had the same in the UK and throughout the rest of Europe. The number of farmers has decreased because their businesses have become economically unsustainable. So any solutions that we come up for food production must be economically sustainable. And then, of course, there's the environment, which I'll major on quite a bit in this talk as well. So what do we mean by intensification? Well, there's a simple definition. It's increasing productivity per unit of land or other resource. It may be milk yield per hectare, or pigs per sow per year, or weight gain per day of animals, feed conversion efficiency. It may be to do with labour, like the number of sheep managed per shepherd, or some other sort of resource like the amount of electricity used by a chicken shed. Intensification does not mean moving from extensive systems to intensive systems only. There's room for intensification throughout the whole spectrum. So what are the big issues with livestock production today? Global demand for animal products is increasing. There's a lot of negative publicity about animal production, as we heard this morning. Competition for land to grow animal feed versus human food. There's pressure on the environment, and we generally need to make more efficient use of resources. So our task is to increase production efficiency whilst reducing environmental impact. And that's been the mantra of my research for a number of years. Looking at global demand, then this is the global consumption of meat, and on a world level it's increased dramatically. But if you look at Europe, then that's kind of plateaued, it's fairly steady. Similarly, North America was on a continual increase, but now that's flattened off. India has a very low demand for meat. But in Africa, there's increasing demand. In the rest of Asia and Central and South America, there's increasing demand. And the overwhelming influence is the China demand. As these developing nations get more wealthy, people have more money, they move towards more animal products being eaten. If we look at the greenhouse gas emissions of animals, then we see that cattle account for about 65% of total greenhouse gas emissions. So there's about 2.5 billion tonnes of CO2 associated with beef production and 2.1 associated with dairy, and the rest of the species kind of pale into insignificance. It doesn't mean they don't have an environmental impact, but it's not so great as the cattle are attributed to. Now, negative publicity is one of the big problems we have. Now, earlier this month, the IPCC produced their, I can't remember if it's the 5th or the 6th report, and it's on climate change and land. Now, this in itself wasn't negative towards animals. Their conclusion was that balanced diets featuring plant-based foods, such as those based on coarse grains, legumes, fruit and vegetables, nuts and seeds, and animal-sourced food produced in resilient, sustainable, low greenhouse gas emission systems present major opportunities for adaptation and mitigation while generating significant co-benefits in terms of human health. So they actually include animal-sourced food within a balanced diet as being a way of mitigating greenhouse gas emissions. So what does the publicity say? Well, the next day the BBC website had plant-based diet can fight climate change, UN. And they wrote a major report on land use and climate change, says the West's high consumption of meat and dairy produce is fueling global warming. Well, I can't find that written anywhere in the report, but that's what they're claiming. They then go on to show a diagram of emissions attributed to different foods, and for beef, they've got a huge range. The high impact systems are basically the ones where rainforest is being deforested, and then you've got various systems in between ending up with low impact systems which are probably either grass-based or the feedlot systems. But these are actually just estimates for different systems, and they're not weighted according to the amount of beef that's produced by different systems. So very small proportion of our beef actually comes from deforested land, but that's the thing that gets the big headline and convinces people to stop eating beef. I'm pleased to see that milk is very low on the list of emissions. It's equivalent to beer. So last night we could have had a milk reception instead of a beer reception. Another diagram that they produced to support their case is how much impact does food have. So they said that a quarter of global emissions comes from food, more than half of food comes from animal products, and half of farmed animal products come from beef. And they very cleverly used journalistic license and made the boxes bigger as you go down and darker red, so beef looks like the big bad thing in terms of global emissions. But you could actually take the opposite view and draw another diagram, which is this one. So we have beef on the left, 7.5%. This is using their numbers, so I'm not just saying I agree with them, but 7.5% from beef. We could draw the conclusion over 90% of human impact comes from activities other than eating beef. So I think that would be a much better message to give to people. And if you look at the difference between a vegetarian diet, I apologize, and a normal, moderate meat-eating diet, then that's, if you change your diet for a day, that's equivalent of driving 5 miles in your car. So just drive a bit less, and you'll save much more global warming than you will by changing to not eating meat. Something that's not talked about, it was alluded to just now when somebody was talking about sub-Saharan Africa, where they need protein. Crops are unreliable. Often they can go for a whole dry period and all they've got left is their cattle, and they're waiting for the rainy season so that they can start producing milk or growing beef again. But if we look at the function of food for some of these populations, then it's to supply protein. And if you look at the protein content, its digestibility, its amino acid balance, and end up with a digestible amino acid supply, which is what people need, then beef is supplying 2.5 times more digestible amino acids than soya, and it's supplying 5.3 times more digestible amino acids than wheat. So converting everybody to a plant-based diet, they're going to have to eat a load more food, which they can't grow anyway because the crops don't survive, and it's just not going to work for a lot of these populations. So that may come back to the limiting population size. You just keep them starving. But that's not one of our objectives. We want to feed the world sustainably. Let's look at resources now. If we look at the utilisation of the land in the world, then 22% is used for growing crops, 39% for growing grass, and 39% is marginal land. And this is a hillside in Derbyshire, near where I live, and if you look carefully, you can see maybe 10 or 20 sheep there. They're using land that would otherwise be totally wasted, and it can't be played out for growing crops. But yet animals apparently use way too much land. But if you look at what ruminants can eat, they eat grass, and they can also eat byproducts, things like sugar beet pulp, distillers' grains, wheat feed, rapeseed meal, all sorts of things. And did some calculations with a colleague, Mike Wilkinson, where we looked at the efficiency of using energy and protein for producing different types of animal products. Pigs and poultry, they feed mainly on good quality feed like wheat and soya. They're 15 to 30% efficient on an energy and protein basis. But beef and lamb are hopelessly inefficient, between 2 and 10% efficiency. And that's because generally you have one cow walking around for a whole year that produces one calf, and that calf then takes a year or two before it is fattened, ready for slaughter. So that's a huge overhead burden on that meat that's being produced. So in energy and protein terms, beef production and lamb production is very inefficient. Milk production is not quite so bad because the cow is producing milk all through the year, and she produces a calf as well. So the efficiency is comparable with pigs and poultry. But if we think about it in terms of competing with humans for food, and look at human edible feed conversion, then pigs and poultry eat some amounts of byproducts, so their efficiency goes up, somewhere between 26 and 40%. But beef and lamb come shooting up because they hardly eat anything that competes with humans. So their efficiency is 21 to 43% on a human edible energy terms, and 30 to 60% on a human edible protein terms. And even bigger stars is milk production, 237% for energy, 164% for protein. You're getting more than twice as much human edible food out of the cow as you are putting in. And so a small amount of human edible food is very useful. Now, Inka de Boer was the one who got the Leroy lecture last year, and she put this very eloquently to look at the optimum use of arable land. So what she said was that we would use the arable land for growing crops, for direct feed to humans, but then the co-products and the residues from the crops, together with grass, would be used for raising animals. And she looked at the relative burden in terms of animal land use of different grams of animal protein in the diet, aiming for a daily intake of 50 grams per day. And the optimum use of land was not for having a vegan diet with no animals. It was somewhere between 9 and 23 grams of protein per day coming from animal products. So it's much more efficient to have animals alongside plants than it is to go to a completely plant-based system. And there are also ethical issues with vegan diets. If they drink almond milk, for instance, that has devastating effects on the water supply in California, but that's a different story. If we look at the raw materials that are used in animal feeds, then this is the UK statistics. By far the biggest proportion comes from cereals, and then it's from oilseed co-products, so soybean meal and some cereal co-products. The majority is fed to poultry, to pigs, and to dairy cows. So 50% is products, 50% co-products, and cereal and soya meal are the main ingredients. Now, it's not that we're always just growing cereals to feed to animals. A lot of this proportion of cereals is actually either feed wheat, which is grown on land that can't grow good enough quality for human wheat, or else it's wheat that was originally intended for making biscuits or bread, and it doesn't pass the quality control standards. So it's got too much gluten, or it's got some other sort of problem with it, and so it then gets diverted into animal feed. So it wasn't deliberately grown for animals, it just ends up being fed to animals. Similarly for soya, a lot of people say, all the soy in the world is grown for feeding animals because about 85% of soya beans are fed to animals. But actually that's 85% of the soya. The soya is grown for oil, for human consumption, and the 85% that's left is soya bean meal that is fed to animals. If we didn't feed it to animals, it would go into landfill, it would rot and produce methane and pollute the atmosphere. So feeding it to animals, it's recycling a waste product from production of human food. It's not deliberately grown for feeding to animals, although in some markets maybe they do feed whole soya and it is grown in that way. And the main species are poultry and pigs. They compete directly for human food, but as I said, they're often using foods that aren't completely suitable for human consumption. Looking on a global basis, then this was a report from FAO. The vast majority, 46% of the feed is from grass, 19% from crops, 8% from fodder crops, 5% oilseed cakes, 5% byproducts, and 3% other non-edible. So you end up that 86% of the global livestock feed intake is not edible for humans. What would we do with all that stuff if we didn't have animals to eat it? And despite what was said by our colleague, that it doesn't take 13 pounds of feed to produce 1 pound of beef, on average, the FAO report found that 1 kilogram of meat requires 2.8 kilograms of human edible feed for ruminants and 3.2 for monogastrics. Livestock consume 1/3 of the cereal production and 40% of global animal land. I've already said that a lot of the cereals were actually grown for livestock that wouldn't, or grown for humans, but they wouldn't meet the standard for humans. Livestock use 2 billion hectares of grasslands, of which only about 700 million could be used as cropland. So it's not that they're competing for land either. The vast majority of land couldn't be used for growing crops. So their conclusion was that modest improvements in feed conversion can prevent further expansion of arable land dedicated to feed production. If we look at the environmental impact of beef, then in typical beef systems, it depends on whether it originates from the beef suckler herd or the dairy herd. In the beef suckler herd, the overhead of the breeding animals is allocated to beef. In dairy, it's allocated to milk. So we can see a threefold difference. in the impacts from beef, cows born in the beef herd or born in the dairy herd. So increasing the number of calves coming from dairy into beef is a way forward, maybe sex semen and crossing more animals with beef bulls. The diet type also affects emissions. So if we look at pasture systems, they produce more enteric methane, but feedlot systems produce less methane but need more nitrous oxide from fertilizer, but they also have faster growth rates. So actually, if you look at pasture and feedlot, then generally the feedlot system has lower emissions than the grass-based system. If we look at dairy greenhouse gas emissions, and this is where I've done a lot of focusing, then 46% of the dairy emissions comes from the feed carbon footprint, and only 39% from enteric fermentation. So it's not just methane we need to worry about, it's the carbon footprint of the feed. We've done some work looking at carbon footprint of different feeds. So grass and grazing have 380, 390 carbon footprint. Maize silage is better, 250, so a switch to maize would be okay. Wheat has a much higher carbon footprint because you do a lot more cultivations. Sugar beet pulp has a low footprint because that is used for sugar production. All the growing is allocated to that. Soya has a very high footprint because a lot of it is involved in cultivation, pesticides, fertilizers, but soya is one of the staple feeds for vegetarians. If you looked at rainforest-produced soya, then that would be over 3,000. So homegrown rapeseed meal, which we produce in the EU, has much lower levels of impact. We did some work looking at trying to look at the carbon footprint of least cost diets based on grass silage, maize silage or byproducts, and generally across all yield levels, as you increase the amount of byproducts, then you decrease the carbon footprint. What about carbon sequestration? Now, as grass grows, it captures CO2, and that then, when the plant dies or its roots die, that's stored in the soil. Now, theoretically, the carbon in the soil builds up, and in permanent pasture, it reaches a plateau and shouldn't increase anymore. But various studies where they've measured it have found between 0.79 and 1.7 tons of CO2 per hectare are disappearing, which they think is in the soil. So a lack of solid data means uncertainty, and it's not included in the IPCC calculations. Now, I did a study with some colleagues in Chagas in Ireland and Jude Kappa from the US, where we looked at high-yield dairy systems fed on grass, or the European system or the US system. Because they were high-yielding, they were producing about a third less emissions than average dairy farms. But when we looked at carbon sequestration, the Irish system was much better because it was based on grass, then the UK, and then the US. But if we ignored sequestration, then the Irish system was slightly worse. So it's a big sort of debate as to whether we should have sequestration. And nobody ever talks about sequestration in animals. As a cow grows, she's laying down carbon in her tissues, and she might keep that carbon locked away from the atmosphere for 10 years or so, but that's never taken into account. Right, I need to move on quickly. So methane, basically the ruminants eat either grass or cereals, cellulose or starch. On a grass-based diet, then they tend to produce acetate, and there's this metabolic hydrogen that's spare, and that's converted to methane. But methane's an essential pathway for metabolic hydrogen removal, and without it, then the whole rumen digestion is messed up. The amount of methane is influenced by diet, so dry matter intake has a positive effect. The more an animal eats, the more methane it produces. The more forage in the diet, or the less concentrates, the more methane produced. Digestibility of forage is negative, so if you have more digestible forage, then it will produce less methane. The more fat in the diet, the less methane, the more unsaturated fatty acids, and the more starch. And then there are various methane inhibitors. Monensin is banned in the EU, so we can't use that. Saponin's the natural soaps, but they're short-lived. Condensed tannins, but they reduce fibre digestion. Essential oils slow down starch and protein degradation. And then there's this new thing, 3-nitroxypropanol, 3-NOP, which acts on the metabolic pathway of methane production and shows great promise. If we look at dry matter intake, then, as I said, there's a positive relationship with dry matter intake, but there's huge variation between animals. There's 2 times variation in methane produced at the average dry matter intake, or you could say that there's 2 times variation in dry matter intake at the same methane production. So can we actually exploit that sort of thing? We did a large study on 2,000 cows on 21 farms and found big variation between farms and within farms, which was all based on the different diets they were fed and the milk yield and the way in which the cows were managed. So there's scope for managing cows differently. The main factor is milk yield. So if I want to produce 1 million litres of milk, from cows yielding 4,000 litres of milk, I'd need 250 cows. If I have cows yielding 10,000 litres of milk, I only need 100. And so if we use the standard IPCC figure for methane, that's 6.5% of gross energy, then you get this decrease in methane production. But if I adjust it for the fact that the low-yielding cows would probably be eating grass and the high-yielding ones would have high concentrates, then the methane production for the herd drops from over 50 tonnes per herd down to about 19 tonnes per herd. So huge effect of milk yield. And the higher milk yield reduces methane by diluting the maintenance requirements. Each cow has a requirement to maintain herself before she produces milk, and with 100 cows you've got much fewer maintenance requirements. But fertility can also affect methane through the number of replacements. And here I've done a graph of conception rate against methane output for these herds, or for a 9,000 litre herd, and at different heat detection rates. So here is the figure where we were, 0.4 conception rate, 50% estrus detection. If we can improve fertility to the levels of the best herds with 60% conception, we'd save 25% of methane. And that has an effect on the energy required for the herd as well. So here we've got the black bars are the energy required for a herd of 100 cows. The cows don't change their energy requirements, but as you increase replacement rate, then the heifers on the farm need more and more energy because there's more and more of them. And if you calve them at 24 months of age, or 30 or 36, there's always an increase in energy requirements as well. So it ranges from 16% to 44% of the energy required by the herd is being fed to the replacement stock. And you can read for feed energy the same as carbon footprints, methane emissions, nitrogen excretion, phosphorus excretion, or profit. So can we breed for low methane? We've just published a paper on heritability. Values in the literature range from 0.1 to 0.3. There's a lot of genetic variation. Methane ranges from 2 to 12% of gross energy intake. And the theory is if you reduce this loss of methane, you can convert that methane energy into milk synthesis so the cows will give more milk. And breeding, therefore, could be a win-win situation. But if we look at the outcome of our EU project, where we measured methane and efficiency in 1,000 cows, and we were linking the cow genome to the rumen microbiome, then we found that as you increase milk yield, so methane production increases as well. That's what you'd expect, because cows are eating more, producing more methane. But when we adjust for dry matter intake, we still get this positive energy, this positive relationship. So more efficient cows were producing more methane. So reducing methane doesn't increase milk yield. The high emitters were the ones that were more efficient at digesting forage. So methane should not be the only breeding goal, but the good news for geneticists is that some cows are more efficient than average and produce less methane than average, so they can target them for genetics. The main message from ruminomics, though, was that there's a core microbiome which is heritable, it's related to methane, and it's related to feed efficiency. So the cow controls her own rumen microbes, all the microbes control the cow, but in future we might be selecting cows based on their genome of the rumen rather than the genome of the cow. Could be interesting. Now, looking at welfare, that was mentioned. Here is our old dairy unit that was opened in 2003. We house our cows all the year round, and to cut a long story short, these cows were given the best possible welfare conditions at the time. They produced 10,500 litres of milk. And then a couple of years ago, we got some further funding. In 2018, we opened the Centre for Dairy Science Innovation. We changed to sand-bedded cubicles instead of mattresses, and you can see on the right-hand side, there's a whole load of cows lying down. They're very comfortable. We have excellent ventilation. All the sides are open. There's an open ridge roof. Slatted floors to take away the manure. And the space allowance was increased from 8.8 metres per cow to 14.1 square metres per cow. So it's not a photographic doctoring or anything. There really is a huge amount of space in that shed for those cows. But milk yield went up by 2,000 litres per cow. We didn't change the diet or anything. But the cows are obviously happy. They're digesting more. They produce more milk. And the somatic cell count in the milk went down, and lameness decreased, and we think fertility's improved. I'll skip over this. Special case of India. This was mentioned earlier on. There's 298 million cattle in India, which is 18% of the world cattle population. But they only produce 2.5 million tonnes of beef per year, or 8.5 kilograms per animal. The main function of cattle in India is they have house cows, as you can see on the left, but they produce manure, which is dried in the sun for use as a fuel. The males are often used, as in the right-hand picture, as draft animals. They do have some specialist dairy systems, as you can see in the bottom left, but there's a huge number of male animals that just wander the streets like teenagers. They hang around on street corners and interfere with the traffic, like you can see on the right. And they're all producing methane and other things. So we can't force India and people to eat meat. I mean, it's against their religion. So there is a government initiative to go around castrating some of these male cattle so that they don't breed, and so that improves it. But that's 1/5 of the world cattle population we can't do anything about. So stopping eating beef in the West is not going to do anything about the Indian cattle. Another system which I really like is the silvopastoral system, and this is a holiday snap from going to the Yucatan in Mexico. Some areas can go good quality maize and good elephant grass, but a lot of areas are like this. The soil is very thin. You can see rocks protruding through the soil. That's not rocks on the top, that's bedrock. So they have small farming systems, milk the cows by hand, but they exploit trees a lot. So on the left you can see young stock being fed with tree leaves. In the middle there's a tree growing a high protein feed that's an alternative to soya. On the right you can see animals grazing trees. So these trees alongside the grass, they produce a really good efficient system. The trees contain saponins which reduce the methane production, and they keep going through the dry season when there's no grass available. So this is a highly sustainable system. The farmers make some profit. They can intensify by growing more trees and having a few more cows, and it's a really good way forward. So just to conclude, sustainable intensification of animal production means increasing efficiency of converting feed, particularly human inedible feed, into animal products. It means reducing environmental impacts, but that often goes with increasing efficiency anyway. It should increase profit so that farmers can keep going and keep following sustainable methods. And all these should be done with high standards of animal welfare. Production efficiency can be increased at all scales, whether it's 10,000 litre cows going to 12,500, or whether it's a cow yielding 5 litres a day going to 6 litres a day. Often there are hidden inefficiencies at the system level, as I showed you with fertility in dairy cows. These need to be addressed. But emissions, profit and efficiency are all linked together, and we need to move forward on all of those and not just focus on emissions. We need to look at the other things as well. And above all, animal production is vital to future food security. Thank you for your attention.
Thank you very much for this excellent presentation. Unfortunately, we're a bit behind the time schedule. Therefore, we will only allow one question if you have one. Everyone is hungry, I guess. Yeah, here's one. Gary.
I just wanted to ask, you're familiar with the work of Pimentel at Cornell, right? I assume you are. And you just disagree with him in terms of the energy inefficiencies, the grain inefficiency, I mean, and the water inefficiencies. You just
yeah.
Okay.
I'm looking on a global basis rather than just somebody within one place. And if you look on a global basis, then you've seen the figures for the amount of feed that is fed to animals. And if you look at the North American feedlot system, then sure enough, 10 pounds of grain to produce a pound of beef. But that just doesn't happen in the rest of the world, where we, as you saw, we can get 40% efficiency, and the FAO figures say it just takes 2.8 kilograms of grain to produce a kilo of beef.
But there are studies that show it's much higher. I mean,
yeah, okay. I mean, everybody does their own calculations. Right. They're not.
Do you disagree? Do you disagree that 40% of the world's grain is fed to animals?
No, but what I said was a lot of that grain was grown for human consumption. It didn't meet the standards, therefore it gets diverted to animal feed.
Okay. Final thing is, with India, they're the largest or second largest exporter of beef. So.
Yeah.
Thank you.
Thank you, Gary. Thank you very much again, Phil. I want to remind you that we still have some of these beautiful shirts available, which I hand over to you, Phil. I hope they make a guest size. I guess this may fit. We also have one for the other speakers, Gary. So there is the EAP logo in it. But I have to tell you, there's also a European Association for Aviation Psychology. So you may tell them that's the EAP. Thank you very much to the speakers. Thank you very much to you. Please have lunch and enjoy.